Hi everyone! Today we're going to study prime and composite numbers. Let us begin by defining some terms. The first is multiple of a number. One number A is a multiple of another number B if there is a positive integer C for which A equals B times C. Example, 35 is a multiple of 7 because 35 equals 7 times 5. Next term, A divides B. One number A divides another number B if there is a positive integer C for which B equals A times C. In other words, B is a multiple of A. Example, 7 divides 35 because 35 equals 7 times 5. We also say B is divisible by A, and we write this symbol A/B, and this symbol is read as A divides B. We also call A factor or divisor of B. Now we go to factorization of a number. A factorization of a number A is a way of writing A as a product of smaller numbers. Example, 5 times 6 times 8 is a factorization of 240. Now let us define prime number. A number P is prime if it is greater than 1 and its only factors are 1 and itself. Examples, 2, 3, 5, 7, 11, and so on. We can see here that the number 2 is the smallest prime number. Also, there are infinite number of prime numbers. A proof that there are infinitely many prime numbers appeared in Euclid's Elements more than 2,000 years ago. Let us define composite number. A number is composite if it is greater than 1 and not prime. That means it has factors other than 1 and itself. Examples, 4, 6, 8, 9, 10, and so on. We can see here that the number 4 is the smallest composite number. Another truth is there are infinite number of composite numbers. Let us go to prime factorization. A prime factorization of a number is a way of writing it as a product of prime numbers. Example, the 240 equals 2 times 2 times 2 times 2 times 3 times 5. In case of repetition of factors, we're going to write it in exponential form. We can have like this, 2 raised to 4 times 3 times 5. The fundamental theorem of arithmetic states that every number has a unique prime factorization, subject to rearrangement of the prime factors. Today we're going to study greatest common divisor and least common multiple. Let us define some terms, starting with greatest common divisor, or GCD for short. The greatest common divisor of two numbers, a and b, is the largest number, d, that divides both a and b, and it is denoted by GCD, open parenthesis, a, comma, b, close parenthesis. Example, find the greatest common divisor of 30 and 42. Let us write the positive divisors of the two numbers. Starting with 30, the divisors are 1, 2, 3, 5, 6, 10, 15, and 30. For the number 42, the divisors are 1, 2, 3, 6, 7, 14, and 21. We can see here that there are common divisors, which are 1, 2, 3, and 6. The number 6 here is the biggest number among the divisors, and we write now the GCD of the numbers 30 and 42 equals 6. The greatest common divisor is also called greatest common factor. The next term is least common multiple. The least common multiple of two numbers a and b is the smallest positive integer that is divisible by both a and b, and it is denoted by LCM, open parenthesis, a, comma, b, close parenthesis. Example, find the least common multiple of 6 and 9. Let us write now the multiples of 6 and 9 respectively, starting with a 6, and these are 6, 12, 18, 24, 30, 36, 42, and so on. For the number 9, the multiples are 9, 18, 27, 36, 45, and so on. In our multiples here, we can see that the common are number 18 and number 36. There are still many common multiples. But we should notice that the smallest multiple is the number 18. So we write here LCM of 6 and 9 is equal to 18. Let us define relatively prime. Two numbers a and b are relatively prime if their greatest common divisor, or GCD, is 1. Example, the numbers 4 and 7 are relatively prime because their GCD equals 1. To check, let us write the divisors or factors of the two numbers 4 and 7. Let's begin with number 4. The factors are 1, 2, and 4. For the number 7, factors are 1 and 7. We note that number 7 is a prime number. Now, with respect to the common factor, and by this time we say that the greatest common factor, that is equal to 1. Therefore, the two numbers 4 and 7 are relatively prime. There are two important theorems here that we will discuss. Number 1, let a and b be two positive integers. Then, a times b is equal to the GCD of the two numbers AB multiplied by the LCM of the two numbers AB. Example, show that 4 times 9 is equal to GCD of 4 and 9 multiplied by the LCM of the 4 and 9. First, let us find the GCD of the two numbers 4 and 9. Let us list the divisors of each number, starting with 4. The divisors for 4 are 1, 2, and 4. The divisors for 9 are 1, 3, and 9. We can see here that the greatest common divisor is 1. So we write here equals 1. With regard to LCM, we will write the multiples of the two numbers. For number 4, the multiples are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so on. The multiples of 9 are 9, 18, 27, 36, 45, and so on. So the least common multiple of the numbers 4 and 9 is 36. Now, let us substitute the corresponding values in the right side of the formula. On the left side, we will write the product of 4 and 9, and that will be 36 equals the GCD of 4 and 9 is 1 times the LCM of 4 and 9 is 36. So on the right side, 1 times 36 is 36. The second theorem is, if n is a composite integer, then n has a prime divisor less than or equal to square root of n. For example, show that the composite number 20 has a prime divisor less than or equal to square root of 20. We note first that the square root of 20 equals 4.47214. Then we write the prime divisors or prime factors of 20. And these are 2 squared times 5. To be specific, the prime factors of this 20 are this number 2 with this power 2 and the integer 5. So we have this number 2 that is less than the square root of 20. So we write the number 2 is less than the 4.47214. I hope you learned something from this video. See you again next time.